This is the microorganisms past paper booklet answers. So the first question is a 6-marker. Describe how you would carry out an investigation into the number of bacteria present in a boiled milk and milk that has been left at room temperature for 5 days using basic aseptic technique and agar plates. In your description, state the expected results. So, aseptic collection of milk samples, bleach the area, shut windows, etc. Flame the loop, the inoculating loop, to pick up your samples of milk to make sure nothing else will grow. Place samples on separate dishes, seal the dishes, incubate at 25 degrees, leave for 24 hours, count colonies on plates with stale milk, less colonies in the boiled milk. Then on the second question is another diagram of someone carrying out the start of aseptic technique, inoculating the loop and then placing it in your sample, put it on the Petri dish and waiting for it to grow. How did the student know when to stop heating the wire loop? In A, it will glow red. Okay. Why is the agar in C sterilized? To kill all bacteria, because we just want to see what happens when you colonize the milk. How would the student know how many bacteria were put onto the nutrient agar in C? He'd be able to count the colonies in D. Next one then, carrying on from that question, is looking at the number of bacteria in a sample of milk which has been treated differently. The results are shown as below. Okay, so raw milk, pasteurized, flash pasteurized, and then UHT, which is the milk that you can buy to store in the cupboard until you're ready to use it. Okay, so it's looking at the number of samples. Okay, in the totally pasteurized, you just got to count the colonies: 1, 2, 3, 4, 5, 6, 7. So 7 in the colonies in a 0.1 centimeter cube sample. Then it says colonies in 30 centimeters, so you need to times your answer by 3, which would give you 21, and then you need to times it by 100 to get from 30 to 0.1. Okay, so that's just filling in the table. The next question then. State the type of milk treated at the highest temperature, UHT, because it had no colonies growing, for the longest time. And you can work that out from here, and that's the totally pasteurized one. So it says 30 minutes. UHT milk is stacked in supermarket shelves, but pasteurized milk must be kept refrigerated below 5. State the reason for this. UHT contains no bacteria, whereas pasteurized milk does, so you need to stop the bacterial growth. Next question then. Quite a lot of information to read here about problems with antibiotics. Which disease was treated with tricycline and for how long was it fully effective? So you need to read through here, and it talks about it being completely effective with cholera. Okay, it talks about it being completely effective with cholera, and how many years did it take? So it was effective between 2000 to 2008. Okay, how many cases of blood poisoning were reported in 2008 compared to 2000? So you had 18,000 cases to 23,000, so there's a difference of 5,000. Suggests why doctors are partially worried that antibiotics are becoming less effective in controlling the bacterium E. coli. E. coli can cause quite serious illness, is very common in humans, so we need to stop the spread. What is the term used to describe bacteria which cannot be killed by antibiotics? It's resistant. You can become antibiotic resistant. How may doctors have a problem of MRSA worse over the past years? Overprescription, overuse of antibiotics. Influenza is caused by a virus. Why is it not possible to treat this illness with antibiotics? Antibiotics do not kill bacteria. Okay. Then it goes on to say, describe the number of changes in bacteria between 20 to 60 hours at 45 degrees. Okay, so it increases steadily, then begins to plateau. Okay, doubles up to 40 hours. So the difference between 20 and 40 is a doubling from 150 to 300, and then it plateaus out. Then it says, calculate the difference between 28 degrees and 37. Show your workings. So I went and found the results for them too, and I took them away and I got 50. How did increasing the temperature affect the number of bacteria present? 37.3 gives a greater number, 45 gives a decrease. So 37 is the optimum temperature for this bacteria to go. 45, then some of the bacteria would start dying Okay. After the investigation, another scientist was asked to carry out the same investigation. Why was this necessary? To test reproducibility. So someone else doing your experiment using the same method, hopefully getting the same results. E. coli in food can cause human illness in humans. State why it must be kept in the refrigerator. When you refrigerate things, it slows the growth or maybe even no growth and reproduction of bacteria. Next question then, looking at a fermenter. So apart from mixing, explain why sterile air is pumped into the fermenter to provide oxygen for respiration. Fungus that produces penicillin requires a source of carbon and nitrogen. In what forms might these elements be supplied to the fungus? Glucose and amino acids. Then it says, how would the pH be controlled? So if the pH goes too high, we'd add an acid because it would bring it back down. If the pH goes too low, we'd add an alkali because it would bring it back up. What is the purpose of the temperature controlled system? If the temperature rises more, cold water is pumped into the tower, lower temperatures, so it lowers the temperature. Need an optimum temperature for enzyme activity. Use the graph to state the time that penicillin enters the stationary phase. So penicillin is up here. So stationary. Okay. So penicillin is up here, but we're looking at here as to when that one starts to level off, because that would mean that this one's going to enter the stationary phase as well. So between 76 to 78. Why is there a high level of protein synthesis in the first 10 hours of penicillin culture? Protein synthesis, we're making enzymes. Okay. The next question you didn't have to answer. That was a level question. Finally, then another 6 marker. Okay. They used to offer you two questions you could pick. Okay, that won't come up now. Obviously, only the one we could use anyway. Describe how the principles of batch culture fermenter are applied in the industrial production of penicillin. All materials are present at the start. Sterile apparatus, pure culture of penicillin, oxygen for respiration, pH buffer, water jacket to control the temperature, method for mixing. So these are all the things that we do to make sure that there is enough control to make penicillin.